Hey everyone, big news. My new book, Developing Mathematical Reasoning, the Strategies, Models, and Lessons to Teach the Big Ideas in Grades 3 to 5, is coming out in March. If you've been listening to the podcast and wondering how to put these ideas into action in your classroom, this book is packed with strategies, models, and the lessons you need.
Y'all, it covers addition, subtraction, multiplication, and division with whole numbers, decimals, and fractions, all focused on building reasoning, not just following algorithms.
You can pre-order now at bit.ly/capital DMR35 lowercase pre-order. Let me do that again. bit.ly/capital DMR35 lowercase pre-order. All right, let's dive in. Hey, fellow mathers, welcome to the podcast where math is figure-outable. I'm Pam, a former mimicker turned mather.
And I'm Kim, a reasoner who now knows how to share her thinking with others. At Math is Figure-Outable, we are on a mission to improve math teaching.
Y'all, we know that algorithms are super cool human achievements, but they are terrible teaching tools because mimicking step-by-step procedures actually traps students into using less sophisticated reasoning than the problems are intended to develop. One breath.
It is a long sentence. In this podcast, we help you teach mathing, building relationships with your students, and grappling with mathematical relationships.
We invite you to join us to make math more figure-outable in one breath. Sorry, I'm just always proud when I can get it in one breath because I don't always. All right, Kim. Hey, how's it going?
Hi.
I'm a little allergy today, so if
I'm sorry.
Clear my throat a little bit. That's
the worst allergies in
Central
Texas.
I know.
I know.
Hey, Cedar, love it.
Yay. Okay. This is a plea to our very sweet podcast listeners. My heart gets so happy when I get to find new reviews.
Oh yeah.
I would like to find some more, please. Dear sweet podcast listeners.
Yeah, y'all, if you have time, please give us a review and rate. It helps people find it, and it makes Kim happy. So like it's a win. It's a win-win.
Okay. I do have this very sweet one from E. Weiland. And it says, from asynchronous professional development to books to this podcast, Pam and Kim make all listeners think and question, is there another way? I started listening and couldn't stop. This podcast is my yard work companion and my dishwashing learning. I truly can't get enough. Keep up the amazing work. I'm so excited to share all I learned with my colleagues and to try some of the younger standards with my own kids.
Oh, that's fun.
I love that. Yeah, that part of like, I want to try some things, and the yard work there. We have a couple of Journey members, the coaching program, who say they go outside and they do the yard work at the same time as they listen.
I love it. Dishwasher
I love that.
Learning. That's brilliant.
So funny.
And I'm noticing it's a 5-star rating and the title is Hooked. I love it. Hooked.
Yes. Thank you so much.
Well,
it's very sweet.
Thanks for being hooked, podcast listeners, and especially E. Weiland for giving us a review that makes Kim happy. And seriously, it helps other people find the podcast. So we really appreciate it when you can take the time to do that. Thanks.
Okay, so today's episode, we are going to dive into a routine that we absolutely love. And this is your heads up if you're in the car, if you're on a run, if you are bike riding, if you're in the garden or washing dishes, you should dry your hands off, grab a piece of paper. This episode is best for you when you can listen, when you have time to sketch out. That's probably true for many of the problems we do in a problem string, but this one is going to be particularly helpful if you can sketch.
Write some stuff down.
Yeah.
Yep. Write some stuff down.
Pause it now and come on back.
Okay. All right. You're back with your pencil.
Yeah.
Oh, wait. Pen.
Pencil.
I'm on my iPad today. Okay. So we call these factor puzzles. Mm-hmm. And I don't know if there's an official name. I think the first time I saw these was in CPM. Okay. Maybe. I've seen them other places. So let's do some factor puzzles. Fantastic routine for anybody grades 3 and up. Today we'll probably focus on ones that you would use in grades 3, 4, and 5. How do I say this? You could use them in any grade.
Yeah.
Yeah. But we're going to do some podcast episodes in the future where we'll do ones for higher grades only, like you wouldn't want to do in 3, 4, and 5. But today you could do them 3 and up. All right. So Kim,
Yep.
This is what I want on your paper.
Yep.
You need to have 4 numbers, and they are arranged so that 2 numbers are on the top and bottom, and 2 numbers are in the middle side by side. So it's kind of like there's 1 number on the top, then 2 numbers underneath that side by side, like centered underneath the top number. And then centered underneath those 2 numbers is a 4th number.
Okay.
So it's, I don't know, what is it like I can say this. It's almost like a rhombus. Like if you think about a rhombus, it's kind of like one vertex and then 2 vertices and then 1 vertex. It's kind
Yeah.
of like,
And typically we draw them like in a like a box. Like, so it's
typically I put a box and then 2 boxes next to each other underneath that top box.
Yeah.
And then 1 box centered underneath that one.
Yeah.
Is there a better way to describe those boxes? I don't even, they're squares. There's 4 squares, 1 and then 2 underneath it, and then 1 underneath that.
Yeah.
4 total. Okay.
4 total. All right.
So Kim, in those boxes, in the top center box is 30.
Okay.
In the 2 side-by-side boxes, 5 and then 6.
Uh-huh.
And in the bottom box is 11. And the question I would ask students, and I'll ask you, is do you see any relationship between these numbers? So again, 30, 5, 6, 11. So what relationships do you see?
The 2 middle numbers, 5 and 6, multiply to make 30, which is the top number, and they add together to make 11, which is the bottom number.
Okay. So just to do one more, so like, can we see if this relationship, those relationships you just said, do they hold? So top box is 60. The middle ones are 15 and 4. And the bottom one is 19. Did the relationships hold?
Yes.
Because
15 times 4 is 60, which is on top, and they add together to make 19, which is on bottom.
Okay, cool. So we're kind of multiplying the 2 middle numbers together to put them on top, and we're adding the 2 numbers together to put them on the bottom. All right, so now I'm going to leave some numbers out.
Okay.
So the top number is blank, the bottom number is blank, but the middle 2 numbers are 24 and 2.
Okay.
Okay, what's on the top number?
That's 48.
Because
24 times 2 is 48.
Okay.
And the bottom number is going to be 24 plus 2, which is 26.
Cool. So you might be bored right now. You're like, really? I mean, it's a little bit of you're practicing kind of multiplying, you're practicing adding. It's not really exciting. But here's kind of one that's a little different. The middle 2 numbers are 24 and 0.5.
Okay.
Or 24 and a half. All right. So what goes on top?
So half of 24 is 12, and that's going to go on top. 24 times 0.5. And then I'm going to add them together and get 24 and 5/10 on the bottom.
Cool. Next one, I'm going to leave out 2 numbers again. So I'm going to give you 2 numbers. This time, I'm going to give you one of the middle numbers.
Okay.
So on the left, I put 7.
Okay.
So you don't have the top number. You don't have the middle right. But you do have the bottom number, which is 10. Now, listeners, like pause for a second. If you have 7 in the middle and 10 on the bottom, what goes on the top and what's the other middle number? Go ahead, Kim.
Okay. I'm going to say that 7 plus something is 10.
Okay.
So 7 plus 3 is 10. So the
with
right side box is 3.
Nice.
And then I'm going to multiply them now to get the top. 7 times 3 is 21.
So it's almost a little bit of a puzzle. That's kind of cool.
Yeah.
It's kind of like you said, I love it. I would have written, when you said 7 plus something is 10, I would have written 7 plus blank equals 10. And I also might say, then therefore 10 minus that blank is 7.
Yeah.
Just kind of like fact family kind of thing.
Would you also write 10 minus 7 is blank?
Yeah.
Like, so you have all 3 of those? Uh-huh.
Yep. Okay, next problem. This time, I'm going to give you a middle number, but it's the right middle number.
Okay.
4. And the bottom number is 6.
Okay.
Go.
So the left side is going to be 2 because 2 plus 4 is 6.
Okay.
And the top number is 8 because 2 times 4 is 8.
Cool. So far, it's not real sexy, but we're getting some multiplication and some addition practice. And we're also kind of doing a little bit of subtraction to maybe find that missing add-end or, kind of missing add-end thinking.
Yeah.
So at this point,
can I interrupt to say this is meaningful addition, subtraction, relationships practice.
Yeah.
Like not like, let's just copy down fact families. Yeah.
Oh, nice. Yes. Cool. Okay, so let's get a little general. If I have these spaces, these boxes set
Yep.
up on a page, and I put in the middle, I leave the top one's blank, the bottom one's blank, but the two middle numbers are the letters C and the letter D. I said
Uh-huh.
letters. C on the left, D on the right.
Yep.
What goes on the top?
CD.
Like
C times D.
C times
Yep.
D. And then what goes on the bottom?
C plus D.
Nice. Next one.
Mm-hmm.
This time I'm going to put C in the same place, the left middle, but I'm going to put on the bottom D.
Okay.
So C is in the middle, left, and D is on the bottom. Okay, what else can you get?
So I'm going to put D minus C on the right.
That seems interesting. Why?
Because that's what goes there. because I didn't want to put C plus something as D.
Okay.
Yeah, because if I subtract C from D, that's what I'll have on the right side.
Nice. And so similarly, when we had written 10 minus 7,
yeah,
on that other one, you're just saying, well, it's that number minus that number is going to give me that missing add-in. Cool.
Yeah.
Okay. So now in the middle, go ahead.
So in the middle, I have D minus C. And so on the top, I'm going to have C times D minus C.
Which is a little complicated looking, but yeah. Nice. So this is an example of algebraic reasoning where we've kind of done a bunch, and I might have done more with students to make sure that they were kind of clear on the pattern, but we've done a bunch of them. And then I'm going to say, let's get a little general. That's algebraic reasonning. We're going to say, if I have this number here, C, then I can add it to D, and I'm going to put that sum down here, like all the relationships that we're doing. One more.
Yeah.
Okay. One more general. So what if I put in the top number? What usually goes in the top box?
Two things multiplied. The left and right multiplied.
It's the product. Yeah. Okay. Yep. So this time the top is D and the middle left is C. So we're missing the middle right and the bottom.
So I'm going to put on the right side D divided by C.
Nice.
And then the bottom, I'm going to put C plus D divided by C.
Cool. I have to write that down, everybody, just to again, ideally this is better. I am reminding myself that I wish when I had done the sort of generalizing earlier that we had done one where we generalized the division that you just did. So a better teacher earlier would have said, ooh, how did you fill that in? And then we would have, with numbers, we would have talked about it was the product divided by the given factor to get the other factor. Yeah. Then it would generalize better the way you just did D divided by C. Nicely done without having a number example before.
Yes.
Okay. Next one. What if I gave you the top and the bottom numbers? We haven't done that yet. Let's have some fun. What if the top number is 21 and the bottom number is 10, but we don't have the two middle numbers? What do you got?
So I'm thinking of two numbers that multiply to 21. So I'm thinking about factors of 21. And I know that 3 times 7 is 21, and those add together to make 10.
So you think the two numbers that go in the middle are 3 and 7? Could they be 7 and 3?
They could.
So you could switch them around. And we could have brought that up earlier, times where we had sort of one number in the middle, and could they have swapped places or whatever? Nice. So you have 21 on the top, and you said that was because you were looking for numbers that multiply together that also added to 10.
Yeah.
And for 21, well, so shoot, I didn't say that the way I meant to. Let me try that again. And of course, the only answers are 3 and 7 because those are the only numbers that multiply to 21, at least. Whole numbers, whole number factors.
Well, I mean, 1 and 21, but those wouldn't add to 10.
But they don't add to 10. Nice.
Yeah.
So let's make it a little bit more exciting or fun.
I'm running out of space on my paper, Pamela.
What if I tell you this is the last one? Does that make you
okay? I'll draw
maybe
some boxes.
Maybe it's the last one. We'll see.
Maybe.
Okay. The top number this time is 36. Dun dun dun.
Fun. Okay.
Anything? What just happened in your head when I say the top?
I was like, ooh, instantly. I was like, what are all the options that could be? Like, I was thinking about what is your sum gonna be? Because then I can kind of like filter through all the factor pairs.
And am I right that 36 has a whole lot more factor pairs than 21 did?
Yeah.
So this one, you got some options here to. Okay. So this time I'm going to put in that bottom number 13.
Okay.
What do you got?
So I know that a factor pair for 36 is 4 and 9, and those add to 13. So I happen to write the 4 on the left and the 9 on the right, but it could be 9 and then 4.
Cool. Cool. Nicely done. One more.
I guess I'll draw more boxes.
You can do it. You can do it. What if the top number is 36? Wait,
I knew you were going to do that. Because I was like, I wonder if she's going to give me sum of 12 next.
Oh, okay.
Is
then I'm not going to give you, yes, it was 12. Okay, do 12, and then I'm going to give you one more. Do 12.
Okay, so 12 is 6 times 6.
Love it when you guess what I'm going to do.
So 6 times 6 is 36, and add together, it's 12.
Okay, last one.
Yep.
Top number is 36.
Yep.
Bottom number is 37.
Yep. So 1 times 36.
Bam.
Yeah. And how fun is that, right? Like if your student is thinking about all the factor pairs and then wonders, what if you give me this sum? What if you give me this sum? What if you give me this sum?
And that's a nice natural differentiation there, that if a kid is not kind of bogged down by trying to find the factor pairs, they can kind of get outside the problem. It's a little bit of an extension kind of. They could be thinking, ooh, I wonder which one's going to come next.
Yeah.
They can also be thinking, kind of like I was indicating a minute ago, that if the number in the top box is 21 or 15, there's not a whole lot of factor pairs. But if I give you 24 or 48, or for heaven's sakes, 96, like something that is just really has a lot of factor pairs, then you're like, ooh, I'm going to have to try a lot of those to see which one sums to the bottom one. Hey, Kim.
Yeah.
I'm a little curious. Why? Go back to if you don't mind, go back to the one that we had 21 on the top and 10 on the bottom.
Yep.
How come you didn't say, I'm thinking of all the numbers that add to 10 and then deciding which of them multiply to 21? Can you talk about that a little bit?
Sure. When I'm thinking about sums to 10, there are quite a few more. There's, 1 and 9, 2 and 8, et cetera, et cetera. And so I would have to filter through many more options. But when I'm thinking about 21, there's only 1 times 21 and 3 times 7. So it's just, there's less to work towards. Less choices.
What about a number like 36 that has a lot of factor pairs? Is that still true? When we had 36 and 13, is it still true that there's fewer factor pairs than there are things that add to 13?
Yeah. There's fewer. And even though we're talking about only whole numbers, I mean, I'm assuming that we're only talking about whole numbers. You gave me one with the decimal, but
I did.
And
only positive numbers so far.
Yeah. So if we're talking about numbers outside of positives, then there's like an unlimited amount that I could get a sum of 13. As soon as we switch to negatives, there are
1 and 14.
So many choices. Yeah, it just keeps going and going and going. Yeah.
So I hear you saying that if you see a product and a sum, that it makes sense for you to consider all of the factor pairs for the product to see if they sum to the sum, versus thinking of all of the add-ins that could sum to the sum to then decide which of those is the correct factor pair for the product.
Yeah.
And teachers, you might be, go ahead, Kim.
You have me thinking right now. I was just, when you said, are there more for 13 than there are for 36?
Yeah.
I was like, I'm pretty sure there's just an extra few more. So then I was like, I wonder if there are ever times where there's more sums than there are factor pairs. And there probably are.
More sums. I think there are more sums than there are factor pairs.
What if it's a prime number and it's just like 1 times 37? Like if 37 is the number on top, then you have one factor pair, but you can sum to, what would that be? You can sum to 38 a whole bunch more times. Oh, I'm thinking the other way. Hello.
Agreed, Kim. Agreed. No matter what the products are, then there's always going to be more. Yeah. And so what's interesting, Yay.
We
Uh,
agree.
all right. So if you teach third grade, fourth grade, fifth grade, right now you might be like, hey, this is a great way for me to get kids to practice multiplication and addition with some
Yeah.
kind of subtraction ideas and division ideas floating in there. But man, if you teach high school and you teach factoring quadratics, you are recognizing some relationships where if you're factoring a quadratic trinomial, you are really thinking about what numbers multiply to this product that add to that middle B term, right? That multiply to C, that add to the B in ax squared plus bx plus c.
Yeah.
And that is so algebra teachers, I guess we should have started the episode by saying, hey, listen, even if you teach high school, we highly recommend that you give some factor puzzles to your students at the beginning of the year and pepper them in your homework and give them these experiences where it's just the numbers that multiply to one product and add to one sum before you ever get the x squareds and the x's and the parentheses and all the things, before all of that floats in there. Get them thinking about these relationships. And one reason I can suggest that is when I began doing these factor puzzles with high school students and really listening to how they were reasoning, I found that there was a whole group of students who were looking at, let me think of all the numbers that add to this sum and then see what if they multiply to this product. Like that was their strategy. And so I started doing problem strings with high school kids to pull out the idea of thinking, wait, there's a much fewer set of whole number factor pairs than there is integer sums. Is that the right way to say that? Integer numbers that sum to that sum. And so kids were like, oh, I really should think about factor pairs. It was also really interesting to hear kids that can't yet look at a number, a product, and think of its factor pairs.
Yeah.
So that's work that we would want to do. And this is one of the ways we can do that. We can help kids by saying, hey, when you look at this number, what are all its factor pairs? And give them experience in finding factor pairs of numbers. To then safely say some.
We have a lot of older grade teachers who talk about they have students in their classes who are additive thinkers. They recognize that they're additive thinkers currently, and they know that they want to move them into multiplicative thinking. And this is exactly the kind of thing that you can do because it takes a factor approach. It's one of the reasons why we also love Number Club Stick and Split so much, because it takes a multiplicative factor approach to break apart numbers rather than just think about, a single fact at a time. Nice. Great for 3-5 teachers, great for older grade teachers who want to build multiplicative thinking in their students.
Yeah. And I'm going to give a shout out. You just shouted out Stick and Split. Love it. I'm going to shout out Alice Keeler on social media. Saw me put in a bunch of factor puzzles and created a Google Slide add-on. So I think if you just Google Alice Keeler and Google Slide add-on for factor puzzles, you can create your own with her Google Slide add-on. So that's kind of nice. Or you can just create your own as well.
Yeah. If you are a grade 3-5 teacher, you can use this series. We call this a problem string of factor puzzles. You can use this string and use it with your students. You can visit the blog, the mathisfigureoutable.com/blog to find the blog about factor puzzles.
Yeah, check it out. You might not even know we have a blog. We have a great blog. We'd love to have you go there. If you go there, you can download a blank sheet that then you have to draw all the boxes that poor Kim was drawing the whole time. So if you want to download the sheet and kind of see the problems that we did and a whole lot more, you can check out our blog. Y'all, thanks for tuning in and teaching more and more real math. To find out more about the Math is Figureoutable movement, visit mathisfigureoutable.com and do a lot of factor puzzles. Thanks for spreading the word that math is figureoutable.
If you loved today's episode and want to go deeper, Pam's new book, Developing Mathematical Reasoning for Grades 3-5, launches in March.
This is the grade band specific follow-up to the foundational book we released last year. It gives you the exact strategies, classroom tasks, and models to help your students build real mathematical reasoning in grades 3-5.
Head to bit.ly/DMR35 lowercase pre-order to pre-order your copy. And hey, if you teach K2, that book's already out.
Y'all, thanks for listening, and we'll see you next week. Keep making math figureoutable.